Building of Residential Optical Fiber Network, a project based on Gigabit Passive Optical Network GPON architecture in Poland. Introduction. This article presents a result of a research related to a concept of an optical network using an optical fiber medium. The presented concept is based on the GPON architecture and the method of connecting of optical fiber network to households. The figures included in the project were prepared in AutoCAD. The developed concept consists of figures constituting an illustrative map of the selected area, including the route of the optical fiber line and distribution of fibers. An example, a connection diagram of all cables and optical devices included in the project. The project includes estimated calculations of the attenuation of the designed network as well as measurements carried out to check the actual values. What is optical fiber? Optical fiber is a transmission medium made of glass or plastic in the form of a cable with a circular cross-section. It consists of several layers, the first of which is a core made of quartz glass in which optical phenomena occur. The core is 50 microns thick and is adequately protected by a plastic jacket and an acrylic outer covering called the primary coating. Thanks to the use of light to transmit the signal, the optical fiber is resistant to electromagnetic interference and the influence of external factors. Signal transmissions in optical fiber is mainly due to the phenomenon of total internal reflection. This is related to the law of refraction of light at the boundary of media with different refractive index, in this case the core cladding boundary. Proper signal transmissions occurs when the generated light ray hits the boundary of the media at an angle, called the critical angle, enabling its complete reflection and transmissions for many kilometers. Architecture of optical networks. Currently, optical fiber is used in each of the three segments of the telecommunications network: backbone, metropolitan, and local. The wide area network backbone segments covers the most extensive area of up to 1000 km, guaranteeing throughput through optical fiber up to 40 gigabit per second. Devices in the WAN network are connected in a mesh topology, which guarantees no signal interruption when one of the devices fails. The metropolitan segment usually covers city areas up to 100 km, guaranteeing a throughput of up to 10 gigabit per second. However, the devices are connected in a ring topology, which does not provide such high resistance to failures as the backbone network. The last type of network in which optical fibers are used is the LAN. It covers a range of up to 20 km and provides a bit rate of up to 2.5 gigabit per second. They are usually built in star topology with one central point called OLT and many access nodes or subscribers. The fiber-based LAN access network is based on an architecture called FTTX, where X is the termination point of the optical fiber to the subscriber. The figure shows exactly where the optical fiber is led from the old exchange, and it is FTT cap, fiber optic cable to a street cabinet in a housing estate or street up to 4 km from the subscriber. FTTC, fiber optic cable to a cabinet located closer to the building up to 600 meters. FTTB, fiber to the building. The signal is then sent via another transmission medium, most often via twisted pair cable to the subscriber's apartment. And FTTH, in example, connecting the fiber directly to the subscriber apartment. Point-to-point and point-to-multipoint topology. Point-to-point and point-to-multipoint topologies describe the method of leading the fibers from the exchange where the transmitter is located to the recipient, in example, the end subscriber. The point-to-point connection is characterized by a direct connection between the exchange and the end user through a dedicated fiber. The receiver has the full signal capacity available to him. The second type of connection is the point-to-multipoint connection, which is characterized by the delivery of the signal to nodes distributing the signal and then to subscribers. Fibers from the exchange are shared for many subscribers, which also divides the throughput dedicated to each subscriber. A type of point-to-multipoint connection are GPON networks. In example, passive optical networks consisting in providing an optical signal to many subscribers using a much smaller amount of fibers. This is possible by dividing the signal in special dividers, which means that one fiber from the exchange can deliver the signal to 64 end subscribers. Concept of an optical fiber network in an example area. Introduction. Optical fiber networks constructed using the GPON technology are very popular at the moment. Use of the advantages of an optical fiber as a medium providing the internet allows to avoid many inconveniences typical for mobile networks or copper technologies. Moreover, the decreasing cost of construction of optical fiber networks allow to create more and more projects based on the FTTH standard. Photo presenting the land of the town on which the designed optical fiber network is located. Illustrative map. The largest drawing included in the project is the illustrative map, which presents the selected area. The project includes supplying of 48 households in the selected town. The drawing was prepared in 1:500 scale on a vector map, which allows to clearly and precisely reflect the concept in the planned area. The illustrative map includes the full path of the optical fiber cable, including blocks that marks adapters and splitters, as well as connected subscribers. The red line means the main line or a branching line of the distribution cable, while the green cables are subscribers' connections. There are also various types of lines. The zigzag means an overhead cable, while the dotted line is a grounding cable. View of sheets of the illustrative map. Aggregation diagram. An inherent element of an optical fiber network project is a diagram that presents the distribution of fibers, often also called forming of cables or an aggregation diagram. This drawing presents a view of all applied optical devices and each fiber of each tube that constitutes a part of designed optical fiber cables. This drawing shows the entire architecture of the planned network and connection of fibers with each other in order to provide the optical signal to each subscriber. Most often, the diagram is presented horizontally and consists of elements arranged in a single line, symbolizing the main line of the planned optical fiber path. Branching lines are located below and above the main line. Each adapter and cable has a detailed description located above the block. Description of an adapter includes the number of the main distribution box to which the adapter belongs, its number, the type of applied adapter, and the location including its address. Fibers are being occupied starting from those intended for the most remote sections towards those for the closest ones. It is important to ensure that occupation of fibers is as optimal as possible. Optical power budget. Another important step in designing of the concept of the optical fiber network is preparation of the optical power budget. In example, a summary of attenuation of particular elements of the path on the road from the old hub to the most remote subscriber to assess whether the designed section does not exceed the allowed value of attenuation and is possible to implement. The described concept assumes that the optical path installation is the design section is 2,179 km long. We had to add 1 or 2% to the calculated cable installation length, which resulted in the optical length of 2,205. There are also 6 wells, 2 detachable connectors, as well as one 1-to-4 splitter and 1-to-16 splitter in the analyzed optical fiber path. Together with the value of optical length and the number of remaining wells and detachable connectors located in the path between the old hub and the planet section, we could calculate the total attenuation value. Here it should be noted that the highest attenuation is provided via splitters. The presented chart shows that over 75% of attenuation present in the optical fiber path comes from the elements that distribute the optical signal. Use of the divisor of the greater division provides significantly higher value of signal attenuation. The total optical length of the optical fiber path and the number of wells also impact its attenuation, however to a much lesser extent compared to the splitters. For this reason, in order to avoid problems with attenuation of the optical fiber line, it is important to use devices of renewed producers, the attenuation values of which will not fluctuate or exceed the provided maximum values. Network parameters analysis. In order to check the correctness of implementation of each project, measurements will be carried out, the result of which must be within specific standards. Examples of such measurements are, among others, a measurement of the attenuation of the optical path and a measurement of parameters of the path using an optical reflectometer. Attenuation of the optical path is measured using an ONT optical network terminal. ONT is a subscriber device which receives optical fiber signal in the subscriber's home. A fiber routed directly from an adapter, including the second-degree common factor, is terminated in this device. This device has multiple functions. One of them is measurement of attenuation of the compiled optical path between the OLT hub and the end subscriber. Results obtained during measurements are summarized with the estimated attenuation calculated in the optical budget. In order to position specific events providing attenuation on the optical path and track the course of the signal inside it, measurements using OTDR optical reflectometer were carried out. For this purpose, one might use a reflectometer dedicated for measurements in FTTH networks. This device operates by sending light pulses on one side of path and then receiving them via a photodetector installed in the same place. In the described concept, reflectometric measurements were made at the wavelengths of 1310 nanometers and 1550 nanometers. Execution of measurements on both wavelengths allowed to more precisely analyze the optical path, since each of the wavelengths is set to another precision related to example wells or splitters. Summary. Application of the project prepared based on the GPON architecture allows to efficiently use a single optical fiber. This significantly reduces the cost of preparation of the optical fiber network compared to connection of supply to a single subscriber using the point-to-point technology. The designed concept guarantees provision of efficient throughput of the network to the end recipients. Based on the analysis of obtained results of measurements, we may state that the implemented optical fiber network successfully achieves attenuation results lower than assumed at the designing stage. This means that it is possible to efficiently use this concept and the GPON technology in various single-family housing estates. Thank you for your attention.